Hello, boys and girls. As you know, we're getting ready to do input and output, one of my favorite lessons. And this is coming from 4.5B, and I wanted to read to you what you needed to know. We have to be able to represent problems using an input-output table. So we're going to be doing that. And numeral expressions. Those are just expressions or number sentences to generate a pattern. So we're going to be learning how to find patterns, but also be able to give a rule to a pattern, okay? Representing the relationship of the values. So the relationship between the values is the rule, okay? And their positions in the sequence. So we're going to talk about positioning in sequences, okay? And we'll see some of those in there. Anyway, so exciting. Here, as I pull this up on our smartboard, this is our magic tunnel. And you just saw our input and output machine. Well, this is a way cooler one, okay? And I'm really hoping that you can see this slide on there, but there are numbers over here. They're kind of hard to see, but this is a 2, this is a 3, a 5, a 7, and a 10. And here's a magic tunnel. So what we do is we choose a number. So I'm going to go ahead and choose for us here 2. And I don't like that because it's just too mute, and I want to be able to see. So I'm going to use blue. We're going to input a 2 in the magic tunnel. And watch what happens if we put a 2 in the magic tunnel. What comes out? Hopefully we can see 18 came out. So I'm going to sit and we're going to put all these numbers in, and we're going to write, and we're going to come up with what's happening in that chart. What's the relationship between these numbers? What's the function inside this machine? What's happening? So let's see. I'm going to put a 3 in next, then a 5. I'm just going to get this filled out, then a 7 and a 10. So how fun is this lesson here? If 3 goes in, 27 comes out. Some of you are already seeing something small comes in, something big comes out. If 5 goes in, 45 comes out. How is that? Are we multiplying? Are we adding? If 7 goes in, 63 comes out. I can tell you are probably screaming at the machine because you know what's coming in next. If 10 goes in, without looking, do you know? 90 comes out, and there it is. Some of you got that. So notice, how is 2 turning into 18? So we can multiply 2 by 9, okay? Or we can add 16. And we got to check both. So if I add 16 to 3, I get 19. Is that going to give me 27? No. And my pattern and my rule is something that repeats. So what are we going to do? Multiply it by 9. Is 3 times 9, 27? Ding, 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 ding. We got that right. So then I'm going to try all of these. And it's important that you try all of them. And especially when you get a test, a lot of times the first 2 can work and the other ones don't. So you want to very much check on these things. 5 times 9 is 45. 7 times 9 is 63. And that's how come you knew that 10 times 9 was 90 and you knew what came out. So what was the rule that's happening inside of here? We are taking our unknown and we are multiplying it by 9. Woo! We have some more. Now, I'm hoping that you can see these numbers. If not, I'll just write them in blue right here, but when I move them, they'll be gone. So I'm going to start with 2, and I'll put a 2 in the magic tunnel, a 10, a 23, and an 8, and 15. And I got to put them in that order since I wrote them in that order. So if I put 2 in, I'm going to use my knuckle here. 2 in, what came out? 20 came out. I'm hoping you're able to see that. That tells me something about my rule. I know it's either addition or it's multiplication. How did I know? I'm putting something small in, and what's happening is it's blowing up that number. It's blowing it up. Okay, let's put in the 10. If 10 goes in, 100 comes out. Okay. 23. If 23 goes in, 230 comes out. That is huge. What pattern do you kind of see going on in these numbers? You see a pattern yet? Uh-huh. You at home are screaming the answer. 8 goes in, 80 comes out. If I put 15 in, you know what's going to come out? 150. Do you see what's happening every time? We're adding a what? What are we adding every time? A 0. So we're multiplying by 10 because we know that we did our tens, multiplying by tens and hundreds, and we know that if we're multiplying by 10, we're just adding that 0. Okay. Oh, new slide here. Let me erase that. Hopefully we can see this one just a little bit better. The white background. I'm hoping. I knew that there was something I fixed on this, but let's just. Okay. Oh, maybe that just sits there. Okay. So here we have our function machine, and we have numbers up here. And instead of making that big nice box over here, we can just make a T-chart. And so if you're at home in your math journals, just make a T-chart and put in and out. So you can pause the video, grab your math journals, and then join us. Okay, if I put 1,000 in, so I'm going to bring 1,000 down, and I'm going to put it through the machine. What come out? 2,000 came out. That gives me a clue. Going from something small to something big. Oh my gosh, we're doing that a lot. If 50 goes in, 100 comes out. What's happening? 7 goes in. Do you know what's going to come out? Oh. Now we're getting into smaller numbers. Those smaller numbers may help us. 5 goes in. 10 comes out. If 2 goes in, wait, how cool is that? 4 is coming out. If 1 goes in this machine, oh, 2 comes out. Look at this. How is this turning into this? You could say times 2 or adding 1,000. But if I add 1,000 to that, is that going to get me 100? No. So we're going to times it by 2. Let's see. And I bet you most of it you got it when we put in that 7. 7 times 2 is 14. Then you went up there and said, 50. 2 $50 bills is 100. We know that. So we like that money. We like talking about money. We know. 5 times 2 is 10. 2 times 2 is 4. 1 times 2 is 2. Okay, because we like to relate numbers with money, so that helps us know 50-cent pieces, 2 50-cent pieces make $1. That helps us. And so when I see $1,000 and I'm getting into $2,000, I knew I could add 1,000. But sometimes we're not thinking of that multiplying. So the rule here is multiplying by 2. We have another function machine. Okay, and this is our last function machine that we have here on this lesson. So let's start out with 1. I'm going to go easy now. Go from the bottom up. If I put 1 in, what come out? Pause this video and see if you can think of your rule already. Okay. Notice when 1 came in, 5/10 come out. Well, 5/10, you better know, is what? Smaller than 1. Okay? I may need some help here. Okay? Let's bring the 2. Let's see if we can figure it out. Well, if 2 came in, turned into 1, I can subtract 1. Can I subtract 1 here? What else makes a number go down? We've tried subtraction, subtracting 1 and subtracting 1, but we didn't get that other output. We did here, but did we get it here? It's got to be a pattern. Let's put 3 in. Let's see if it helps us. Oh my goodness! This is getting so hard. I can't subtract, so what must I be doing? You got it. We're dividing. What could I divide? So let's keep going. Because sometimes the more numbers we put in, the easier it helps us. What can I divide 4 by to get 2? Thinking of money again. Could I divide 50 by? If I had, gives me, that's quarter. It's a big clue. I bet some of you know already the rule. We're going from something big to something small, so we're subtracting or dividing. We know we're not subtracting because if I subtract 1 here, I'm not going to get this, and I do get this, but I can't keep subtracting 1 because I'm not getting my output. Oh my goodness, so I know then it's got to be division. So as the more we keep going, notice as we got to some of these, I bet you noticed if you divided that by 2, and you know from money, if you had 50 cents and you divided it into 2 parts, you'd get 2 quarters. 1,000 divided by 2, 3. Oh, that was the tough one. Well, think of half of 3. You get, if I wanted to split 3 into 2 equal parts, I would get 1 on this side, 1 on this side, but then I'd have to take a half and put it over here, that 1 left over, and a half over here, which is the same as 5 tenths. 1 and 5 tenths. So remember, 5 tenths represents a half. And that just gave us the clue for why 1, if I divide it by 2, it's going to be half. Because half of 1 is half. And then if I divide 2 by 2, I'm going to get 1. So the rule here, toughie, was a divide by 2. Good job today. Today you're going to be looking at rules and patterns and hopefully matching patterns with these rules or finding the rules for these input-output charts. But it's way fun because we can narrow so many things down and play with these numbers. Go back and rewind this video. I say that all the time to help you with anything that you may not have understood.